This is actually, we're jumping to chapter 8, this 8.1, section 8.1. And on this section, we're going to be dealing with polynomials. So let's first understand what a polynomial is. Polynomial, the word poly means what? Anybody? Many. So when you're talking about a polynomial, we're talking about many terms. It's just a variable expression. So you need to know what a polynomial is. It's a variable expression. Number two, the degree, the word degree. You guys know what degree is? You guys ever tried the deodorant degree? No, I'm just kidding. It has nothing to do with that. The degree is the highest exponent of the variable expression or variable. The highest exponent that you see. Okay? Standard form is a polynomial written in order from largest exponent to smallest. And at the very end, you have constant, which brings us to this definition. But before constant's just a number. But over here, leading coefficient is the coefficient, the number that's out in front of the whole polynomial when it's in standard form, when it's in order from highest exponent down to smallest. And the constant term is the number at the very end of a standard form polynomial. So, for example, let's say you had x to the second plus 3x minus x to the third plus 5. Is that polynomial in standard form? Again, standard form means a polynomial, it says up here, a polynomial written in order from largest exponent to smallest. Is this in standard form? Definitely not. Because the highest exponent is what? 3. Right? And of course that brings the word degree. So these first definitions you need to know, so when we refer to them you'll understand what I'm talking about. So this polynomial, it has many terms. There's 1, 2, 3, 4 terms, right? Many terms. The highest degree, or the highest exponent, which is called the degree, is 3. And it's not in standard form, because if it were in standard form, it'd be written in order from the largest exponent down to smallest. So if I wanted to write this in standard form, what I would have to do is put the highest exponent term first, and that would be this guy right here. And you know what, I messed up on that because I should have included that minus sign. So this is really a negative x to the third. That's the first term when you rewrite it in standard form. Your second term would be a positive x squared. That's right here, the first term on the original. And then your next one should be plus 3 to the x, and the final one should be plus 5, the constant at the very end. So I hope we understand that this is not in standard form. This one is in standard form. Why is this one in standard form? Because you have the highest exponent 3, 2, this is an invisible 1, and then the number without a variable at the very end. This number at the variable end is the variable without a variable at the very end is called a constant. Okay? So once again, standard form, highest exponent down to smallest, which means no variable, just the number without a variable, which is called the constant. Okay, so that's how to rewrite in standard form. We need to be able to do that on today's assignment. In addition to rewriting polynomials in standard form, we also need to be able to classify polynomials. So this is going to be kind of like giving a polynomial a first name and a last name. So I want to pause it right here. I want you guys to pull out your notebooks and copy this down. So once again, what I want you guys to understand is that we're going to be classifying polynomials. So for example, the polynomial up here that we rewrote in standard form, it actually has a first and last name. Okay, it has a first and last name. And the first name is based on, it says over here, the first name is based on the degree. So if your exponent, your highest exponent is 1, it's linear. If it's 2, it's quadratic. If it's 3, it's cubic. If it's 4, it's quartic. So what is my degree on this one that we did as an example? What's my degree? It's 3, correct? The degree is the highest exponent. There it is. So the degree is 3. So the first name of this guy up here is cubic. Now I already know these by memory. but that first name comes from the degree being 3, which is cubic. Okay? Now, how about the last name, the second name? Well, the second name is based on the number of terms. So if there's only one term, it's a monomial. After all, mono means one. If it's 2 terms, it's a binomial. After all, bi means 2. Bicycle, right? 2 tires. But on the other hand, 3 terms, that'd be trinomial. That's obvious. Tricycle, 3 tires, as opposed to bicycle, 2 tires. 4 or more, we're going to just call that many terms, which is polynomial. Okay? So the first name of the example that we did was cubic because the degree was 3. How about the last name? How many terms do we have? 1, 2, 3, 4. Monomial would be just 1. Binomial would be 2. Trinomial would be 3. 4 or more, we call it polynomial. So the classification of this guy is a cubic polynomial with the first, that's with the first and last name. You got it? Okay, so once again, I wanted you guys to jot this down in your notes. And what else could we put? We could put first on this side, and we could put last on this side. Because the first name is based on your degree, your highest exponent, and the last name is based on the number of terms, how many actual terms you have. Now, there's one more that, let's go to the first name, and down here, let's say we had a power of 5. Power 5. Doesn't look as cool as a computer print, but power of 5 will be, anybody? Quintic. Yeah? That's not really that important, you know. Power 5, quintic. I'll accept just a 5th degree polynomial, but quintic is the highest that our book goes. So if you look at the book, it'll tell you, oh, power of 1, linear, power of 2, quadratic, power of 3, cubic, power of 4, quartic, power of 5, quintic. Anyway, just wanted to add that on there. So hopefully you guys are familiar with these words to give you the first and last name of any polynomial. So, down here, we have examples. I'm sorry, did you guys finish copying? No? Okay, let me go back. Okay, copy it. I want to hit pause. If you're at home doing this, hit pause, and then we're going to move on. Moving on. Okay, so examples. Based on your notes that you just copied down, if I just gave you the number 6 and I told you classify it, give it a first and last name, what would the first name be right here? Constant, and the second term, monomial, which is ridiculous because that's just the number 6. But if we're using the notes from above, constant, because there is no variable on it, monomial, because it's just one number, yeah, constant monomial. We're never even going to really ask you to classify just a number. That's ridiculous. How about this guy? What is your degree? 1. So what does that make the first name? Linear. And how many terms is this? It's 1 term, so monomial. So this is actually a linear monomial. How about the next one? What's the degree, the highest exponent? Yep, it's 1, so it's linear, but how many terms? 2, so binomial. And the next one, what would this guy be? Based on your notes. Quadratic trinomial. And this next one, highest exponent is 3, which means it's a what? Cubic binomial. And last but not least, what's that last one? Cubic trinomial. Well, all right. I think we got it. Let's move on to the actual worksheet. We only have about 5 minutes left, so we're going to kind of rush through this. This is really an easy section, one of the easiest sections in Algebra 1, adding and subtracting polynomials. Because adding and subtracting is really just combining like terms. Okay? So let's look at number 1 here. There's a linear binomial and a linear binomial. And if we were to add these linear binomials together, it's really just combining like terms. There is nothing to distribute out here. It's a plus sign. If you distribute the plus sign, it's going to stay the same. So all you really have is combining like terms. Because there was nothing to distribute out here in front of this parenthesis, you could just ignore the parenthesis. And over here, because the plus sign, if you were to distribute it, it won't change anything. You could ignore the parenthesis and just bring down the minus 7y minus 1. And now let's just combine the y's with the y's. Notice that I included the sign in front. 4y take away 7y, that's a negative 3y. And at the very end, I do my numbers, the 5 minus 1, which is a positive 4. Now notice that I made the effort to combine the letters first and the constant value at the very end, the numbers at the very end. That way it's already written in standard form. And it'd be good practice to classify your answer. This answer right here is a linear binomial. You don't have to classify it. I don't think the solutions actually have it classified. But let's move on to a different one. So adding's cake, but subtracting is the one that's a little bit more interesting. Like let's do number 5 down here. You see, number 5, there is no number to distribute in front of this parenthesis right here. There's nothing out here to distribute. But on this parenthesis over here, you have a minus sign. So what you have to do is take that minus sign and distribute it, because it actually does change everything. It changes all the signs. Now, on the one above, on this guy, we had a plus sign. If you distribute a plus sign, nothing changes. So it's totally pointless to distribute the plus sign. But on a minus sign, you have to distribute it, because the second part of it now becomes negative 7a squared plus 7a minus 5. It changes every single sign in there. Now, like we said, on the first part, there is nothing to distribute out here, so nothing changes on this first quadratic trinomial. So I'm just going to rewrite it. 5a squared plus 6a plus 2. And now let's combine the like terms. Let's start with the highest exponent. That way we could start writing the answer in standard form. Like if you start with the numbers and you write down the number first, you know that's not right, because that should be at the very end. It's your constant. So let's start with the a squared values. 5a squared minus 7a squared, that will be negative 2a squared. Then if we go to the a's, you have a positive 6a with a positive 7a. That's going to be a positive 13a. You're just combining like terms. That's like if you had 6 apples and you had 7 more apples, you have 13 apples. Oh yeah, that kind of reminds. If I have 6 apples in my left hand and 7 apples in my right hand, what do I have? No, not 13 apples. I have big hands, because you get what? Okay, that's the worst joke ever. Nobody laughed. Thank you. Let's move on to the constants. We still need to combine the constants. What's 2 minus 5? That's minus 3. Negative 3. And ladies and gentlemen, this is your final polynomial answer. And if we wanted to classify it, we don't have to, but if we wanted to, that would be a what? So that'd be a quadratic trinomial. So the only one you really have to do some work with is the minus sign, because you have to distribute the minus sign. Okay? If you don't have a minus sign, it's pointless to distribute the plus sign. So all these are pretty easy. And like always start with your highest exponent terms. By the way, you could combine x squares with x squares, x to the thirds with x to the thirds, x's with x's, numbers with numbers. But you can never combine x to the third with x squared, obviously, when you're combining like terms. So, down here in this middle portion, it says, determine whether the expression is a polynomial. And I might as well tell you this. The only time it's not a polynomial is if you have a variable in the denominator. Okay? Like right here, you have x to the third down there. And the reason why is because if you ended up with the input of 0, then that would make it undefined. Okay? So 14 is the only one that's not a polynomial, I think. If we look at these other guys, we could classify them. And even though it says just state it if it's a monomial, a binomial, or trinomial, I would rather you classify them. I ran out of time.